Well, now we have our last lightning talk of the day, which is Zack, who will be talking about Couchbase Lite for .NET.
Cool. Hi, everybody. My name is Zack Gramana. I'm the Senior Product Manager for Couchbase Mobile. I'm also the creator of Couchbase Lite for .NET. So what is Couchbase Mobile, you ask? Well, great question. So it's a system comprised of three components, Couchbase Lite, which we'll be talking about today, a application gateway called Sync Gateway, and Couchbase Server. And the way this works is as your devices are syncing with the Sync Gateway is then storing those and persisting those documents and your data into a Couchbase server cluster. So today we're just going to focus on Couchbase Lite for .NET, which is a NoSQL mobile database. So that means it runs in process and has a very small footprint. So the assembly plus its dependencies are like 500K. So what does that mean? So you get a document-oriented database, a MapReduce index and query engine, you get change notifications, and you get sync. So what does it mean by document-oriented database? Well, documents are essentially dictionaries with versioning. The data inside of dictionaries are immutable. They are schemaless, so no more object relational mapping and impedance mismatch and migrations. And here's a very basic code sample of what it takes to save a document into the database. So we just get a shared we get a handle to the database, in this case named foo, from this manager object. And it follows the get or create semantic here. So you'll notice sort of highlighted. We're asserting that debug or the DB variable is never null. Once we've got to handle the database, we just ask it for a new document, and we call put properties, which is effectively save, and we just shove in a good old-fashioned dictionary. Now, the way everything gets persisted on disk is JSON-based. So the nice thing is you can just shove entire object graphs into your document. So you don't have to worry about having multiple tables and figuring out how to normalize your data and denormalize your data. You just shove objects into your document, and they come back out again. And as we can see here, we have a deeply nested object graph with other nested objects, yada, yada. Incidentally, this is from the open source conference app we built last year based on Xamarin Forms, which was very, very successful and very popular, and you can get it at the URL below. Next, we have MapReduce query indexes. So you get to build the indexes to your data in C#, which is, it may sound like a small, trivial thing, but it turns out to be a very pleasurable thing, because now we can debug our data just by setting breakpoints in our preferred IDE. And the results of our MapReduce index allow us to do incredibly fast indexes, even over very large data sets. So here's a complete example of what this means. So we, again, ask for a view, which will always be null in this particular case, and then we give it a map function, which is just a good old-fashioned lambda. In this case, we're going to build an index that lets us sort all of our documents by this last modified timestamp. And as we'll see next, it'll be in descending order. So we just get the key. If the key's there, then we emit a key and a value. In this case, all we care about is the key, so we don't even need the value. We can save space by just emitting null here. It's as easy as that. We can call emit multiple times if we have lots of data we want to index from a single document. Then to actually get a query, we start with one of those view objects, and we just call create query. And in this particular case, I'm going one further step and turning it into something called a live query. So we can set our sort order here. We can also subscribe, as you'll see here, a change notification or a change event handler. So that way, whenever my query changes, then I get a notification. This effectively gives me infinite queries that keep returning data. Even once all the records in the database have been enumerated, if by CRUD operation or replication new objects come in, I'll get the change notification. So as we've been hinting here, we have these events that we can subscribe handlers to. They have multiple scopes, so database level, query level, replication, even documents. And as you guys saw from Frank Cougar's presentation, when you can code this way, in a very event-driven way with immutable data, it cuts down on a ton of cruft code. So we can also get document-level change events. So sync, you get full multi-master replication. That can be continuous or a one-off. And we can have multiple topologies. This is a complete soup to nuts. This is what it takes to go from an offline local database application to a fully bidirectional synced one in near real time with authentication and change notifications. We support all the operating systems on the top row and all the .NET programming environments on the back row. You can do these really cool topologies where you've got star topologies and tiered topologies. But one of the coolest things is the mesh topology. So you can have peer-to-peer sync just between a cloud of devices. So next steps, developer portal, you can get more information. We also have some sweet discourse forums, Google mailing list, or you can reach out to me directly. And that's it. Thanks.
Thank you, Zach. And thank you to all of our speakers.